Welcome again to another one of our webinars offered by AXYZ Routers. My name is Noel Archie. I am the manager of the application group. Today we'll be talking about aluminum plate. When you're cutting aluminum plate, what are the things you need to consider in terms of tooling, vacuum tubes, the chip collection, how would you clamp or hold the material to the bed? We will be processing the material on our METALWORKER platform. This is our newest machine. It has a touchscreen system integrated into it. So we will look at how, when, and why you would do certain things when processing aluminum plate. What are the things I need to take into consideration? Well, the first thing, cutting any material, whether it be acrylic or aluminum, the type or the grade. So I'm using 5052, 6062, 3000 grade, because all of those things will have an effect on my process. Some materials have a higher machinability level than others, so it may mean that I have to go with different RPM, different feed rates, more or less oil. So my first thing is, what's my grade? Then I start looking at, what's my material thickness? What is the best tool I would need to use when cutting this material? When I look at material thickness, one of my main criteria is cut length. I want to make sure my cut length is long enough to cut through the material, but not so long to affect the rigidity of the tool. Because if my tool is a lot longer than I need it to be, then I can start getting deflection in the tool. It will affect my edge finish, my feed rates. So I'm trying to maximize my setup. So now I've figured out my grade. I've figured out my cut length. Now, next thing is my diameter. Well, my diameter relates internally to internal shapes. So, for example, when I look at this internal corner, what is the maximum radius I can use in that corner? That will dictate the size of tool I want to have. Again, I want to maximize my tool size. The bigger the tool, the more aggressive I can cut, the more I can really control my edge quality. A smaller tool will affect my feed rates. I have the higher possibility of tool breakage. So I've looked at grade, I've looked at cut length relative to material thickness, I've looked at tool diameter. Okay, great. So those are the primary things I'll look at first. So now I know the tool I'm going to pull. Well, the next aspect of the tool is tool geometry. Do I want a 2-flute, 3-flute, O-flute? What do I want in terms of what I'm going to be doing? I also have different coatings that I can basically look at. So when we pull a tool, we basically looked at all these different aspects, and then we get to tool geometry and do we need coating or not. Now I've got my tool in hand. I know exactly what tool I'm going to use. The right cut length, the right diameter, coating. Now I start looking at the machine itself. Okay. How am I going to hold the material to the deck? Am I going to vacuum hold it down? Am I going to clamp it? Is it going to be in a fixture? All those different things have one thing in common. Doesn't matter if I'm vacuum holding it, I'm clamping it, or holding it in a fixture, it has to be rigid. Rigidity is the name of the game, as they say. If my part isn't rigid, I will get chatter in my cut. I can get tool breakage. It will affect my finish, so I want to be sure that it's securely attached to the deck. Okay, let's start looking at the machine itself. I need to be sure my machine is rigid in itself, so that when I place that material on it, there's no vibration in the machine, in the head, because all the vibration that I get when processing any material, especially something like an aluminum plate, ends up in the tool. And if it ends up in the tool, it ends up in my edge. So I want to be sure my machine is rigid, my material is rigidly held to the deck, so now I'm ready to go. Okay? Then I start looking at my tools I'll be used for cutting. I have different spindles. So we'll be using a 10 horsepower HSD spindle. We have a mister system attached to it, because we want to basically apply just enough coolant to the material and the tool where they engage. That will affect my edge quality. It will affect how fast I can cut. And the last aspect of that is my chip collection. Chip collection, again, the chips are being removed, you're drawing the heat away from the cut. It also affects your cycle time in terms of processing sheets. If I have to basically spend 10-15 minutes cleaning up between sheets, that will actually increase my cycle time in terms of parts per minute or parts per hour. So when we configure this machine, we've looked at all the aspects right up to the point where we're even looking at how well we collect the chips before we even start cutting. Now we're ready to go. Well, next thing is now we're going to take the file and move it into our CAM software. Within our CAM software, I'll take all of those things into consideration. I know my material thickness. I know my smallest inside radius, so I know what tool I'm going to pick. I know what kind of edge quality I want, so I know what kind of feeds and speeds I'm going to look at. I might also decide at that point, I want to do multipass. Multipass might seem like it takes longer, but what it does, it actually tends to be quicker. With one pass, depending on the tool size, I may go a lot slower because I cannot be as aggressive because I'm taking a lot more material off. Where with multipass, I can go a lot quicker because I'm taking smaller bites. The downside of doing a multipass cut is I might see step marks. Well, what we'll do in that case, we will then look at doing a cleanup. So that cleanup will basically go around in one pass, taking off 10, 15 thousandths of an inch. That will now give me that nice, beautiful edge I'm looking for. Once I've sat down and I've looked at all those things in my CAM software, I'm ready to cut to a certain point. I need to look at if I'm doing a nested job, what's my sequence? What is the cut order I will be using to cut the parts? I don't want to be cutting and jumping from shape to shape and not being efficient in my process. So I will pick a sequence that's very efficient so I can basically reduce my cycle time. Another aspect of that is your start point. Where am I going to start and finish? I typically start to the right, top. The reason being I'm always, like I say, cutting to my strength. I want to end my cut where I have a lot of material, keeping it rigid in place so the part wouldn't move. Another aspect of holding parts in place, depending on the size of the part. Again, vacuum hold down or any kind of hold down. If I'm just holding a sheet, as I cut the part free, there's a possibility of motion or movement. So I might look at adding tabs in. So I might put one or two or multiple tabs in it. One of the things we do a lot when we cut aluminum, we might make a tab that might be ½ inch wide, but only 10 or 15 thousandths thick. So it's almost paper thin. So it's easy to just break it off and a quick deburr and it's gone. But again, tabs are a function of part size. Okay? So now that we've discussed all the different aspects of getting the job ready, we'll now jump into the software and review the process to create the file before we then move to the machine and cut it out. Now we'll take a quick look at the part that we're cutting in regards to how it was set up. You can see the basic shape on the screen, and to the right you'll see the different layers that I'm using. One of the things that we've done, we've assigned tool parts to layers, which makes the process quite easy to duplicate if I had to do this process again. So if I looked at this particular layer, you can see it automatically picks the shape that I want to apply the tool path to. I can designate the tool. I can designate all my parameters in terms of feeds and speeds that I would require for that tool. Plus, if I need to do things like ramps or tabs, it can all be added in at this point. Once I am finished, I simply hit calculate. Then it will show me the tool path. I can simulate it so I can see exactly what that will look like. I'm just simulating the whole job. If I double click on the scrap, it shows me the finished part. So I can now zoom up on it. I can move it around to see what it looks like. Okay, so I'm going to go back to the 2D view for a second. So as I said, I have the one particular toolpath selected, automatically selected the geometry. If I want to go in now and just calculate all my different toolpaths, I'll simply hit calculate all. It will tell me these are the different toolpaths. It will show me what the profile or terms of the motion would look like for each toolpath. If I want to see the actual tool diameter, simply click on that icon. Now it shows me exactly what that tool will do in terms of following the path. If there were things that I wanted to be concerned with, things like inside radiuses, I can now see that maybe I need to use a smaller tool because I want to get a tighter inside radius because of the tool I'm using might be too large. So I can address those things now before I get to the machine. Once that is finished, I will simply save the job. It will show me all the different tools that are being used in that job. So I can basically verify that those tools have been loaded up in my tool changer. I save the toolpath and I simply transmit it to this machine. That's basically the process for getting the file ready to run.